Today I'm presenting how do we optimize our AI workload, which is mostly we are using GPUs and CPUs. How do we optimize it using Kueu on Kubernetes? That's summary of what I'm presenting today. I wanted to explain what are the challenges we are facing right now. So, like we have been using a lot of GPUs regularly because of a lot of scalability and more AI workloads increasing day to day, and because of this rapid expansion in AI workloads, there has been an unprecedented Kubernetes clusters which are getting overloaded with just couple of requests, and with that it's getting difficult for organizations to optimize their storage, and also there have been a lot of bottlenecks and inefficiencies. In order to eradicate that, there is this open source application called Kueu, which will schedule each and every load which is going to the clusters, and it will basically check if there is an empty cluster, and it will go and borrow, because it's empty, they can go and borrow the cluster for some time, and it's basically prioritizing based on their quota, which is nothing but their present status, if it's empty or if it's already filled. So these are the challenges, and understanding this problem space. So like I said, there has been like a static quota in Kubernetes which leads jobs to sitting idle. So because there have been a lot of AI workloads and GPUs, CPUs, we want to optimize it as much as possible so we can save a lot of money and storage space for many big companies who are investing in their cloud spaces and also server spaces. So in order to do that, again, there are like many like I said, there is like a GPU fragmentation. Without intelligent batching, it's difficult for us to directly go and use a Kubernetes cluster. Kubernetes cluster is nothing but orchestration cluster, and I just wanted to explain, it's like an infrastructure where most of our cloud platforms are based on. So I think this problem has been there, and there are like a couple of other open source applications which are working on this problem, like KIA scheduler and Kueu, etc. So I'll just explain what is Kueu again. So Kueu is it's a Kubernetes native job queuing and resource management system. So it's again native to the Kubernetes application, so you don't have to worry about any dependencies or any new jobs or something like that. So, and also it's compatible to many other MLOps platforms like Kubeflow, Airflow, and Argo workflow, etc. So it's, if you have a Kubeflow, you can directly have it, you can worry less when you are deploying something on a GPU, I would say that, and it's always production ready, because this battle is already tested in thousands of AI workloads. So it's gonna ease a lot of work for many developers and many project leads, I would say. And this is just like what are Kueu core concepts. If you can see, there is like a cluster queue, local queue, admission checks, resource flavors, and cohorts. These are like queues. Queue architecture is based on these 5 fundamental building blocks, and a shared like cluster queue is like a pool of resource accessible across multiple namespaces. If you know, like each organization has a namespace, and they try to assign each team to a particular namespace and then assign it to a cluster or a pod. But in order to make it easy, there is like a shared pool of resources which are accessible in this Kueu cluster. And yeah, I'm just moving to the next slide. So this is, like I said, this is like an architecture overview, how the step-by-step process, how the Kueu works when you are deploying something on a Kubernetes. For example, team submits AI workloads through familiar interfaces, like if you're using kubectl and or any other MLOps platforms, it will directly go to local queue, and then instead of directly going to the Kubernetes scheduler, it will we have this queue controller in between, which is, like I said, it's an intelligent admission control which will decide how to schedule each job in order to optimize our GPU functionality. Yeah, this is like overview of that. And why do we need queue? Like, can't we directly use a Kubernetes cluster? It's why do we need this altogether? So there are definitely some drawbacks with Kubernetes. I can say there is no queuing. For example, if there is a load, or there is some there is a cluster which is getting filled or which is not being used for so long, you can't borrow something from that cluster, or you can't use that space with Kubernetes. Kubernetes clusters are not that smart, so there is no queuing, and static resource quotas are not possible, and there is no batch optimization, which is a main reason why we are using queue. And in order to make it better, we are using queue scheduler, which is a fair and priority based allocation, like I said, and it's definitely very efficient GPU batching, and it definitely helps in smart queuing and rich metrics. I wanted to talk about numbers, like how is it helping our companies. So if you see, there is like a 35% of high GPU utilization. Many companies like Microsoft and NVIDIA are already using Kueu and KS scheduler on the regular basis in order to optimize their GPU utilization. And there is 40% faster job starts. If you see, like, reduced average wait time has been reduced by 40%, and also it can support multiple teams, multiple research groups at the same time, and it will not take a lot of extra space. And yeah, this is like a simple installing. How do we install Kueu in using kubectl and regular Linux platform? And yeah, this is like defining how the resource flavors work. So what is a flavor? Flavor is like, there are type of GPU types, I would say, and they have like separate high memory and standard nodes. Based on our requirement, we definitely categorize flavors, and we want to assign a particular task to them, so we can directly use them. And this, if you see, this is a code, API version and resource flavor metadata. This is where we can update our flavor data and apply cost aware scheduling policies based on that. Yeah, these are like simple steps. How do we create a cluster queue? Yeah, and creating a local queue. Again, local queue connect team namespaces to cluster queues. Like I said, there are many teams, or like local teams, which is where we have this cluster queues. So in order to connect to any local queue, like the order, we can use these ways. Yeah, I can skip to next slide. Yeah, so like I said, there are many platform integrations, and here Queue's flexibility, it's definitely extensive, and it's popular among multiple integrations like MLOps and data science platforms. If you see, there is Jupyter Hub, which is again very famous. It enables in we regularly use those for college purposes, and also queue aware job submissions, and run resource efficient batch pipelines, and again Ray clusters. So in order to make the queue efficient, we also need to track everything in our Prometheus and Grafana metrics in order to understand like what are the key metrics to monitor queue, like because queue exposes rich Prometheus metrics that provide like deep visibility into queue behavior. Like if you see, there are like certain commands where jobs waiting for admission successfully, admitted jobs, and current resource consumption. These are like this is what we use in our regular Kueu platforms, and yeah. So like I said, the performance lessons learned. So what are the performance? How is it getting actually benefited? So it's not like a small difference. It's like 20 to 50% faster job starts, and also less idle time. Like I said, if there is a cluster in Kubernetes which is empty and it's not it's idle for a long time, and in order to borrow it and use it for efficient use, we definitely take help of Kueu, which is again reducing it to 25%. And we are also integrating it with CI/CD pipelines like Jenkins, Kubernetes, etc. And also we are leveraging cohort scheduling with this. So these are like major lessons or like benefits why we are using Kueu. Yeah, these are like real world deployment tips, how we can deploy each, like how we can deploy it, like structure codes by namespace, use preemption cautiously, and test with synthetic workloads, and combine with cluster auto scaling. So this is like a proof of concept to production, because it requires like careful planning and testing. We can, that's how we integrate Kueu with on top of our Kubernetes. So these are like battle tested recommendations which will help again, if you it will make sure it's working perfectly without any pitfalls. Yeah, I don't have much time to give a live demo, sorry for that. Just final takeaways, how we can use, if not Kueu, any scheduler. It's basically a mediator between our job submission and job scheduling applications. It will definitely save a lot of money, time, and improves efficiency for a lot of organizations. And definitely we should start, I think there are many companies which are already using it. I think we should start using more and more in order to save definitely time and money. Thank you.